All right, so what we're going to be talking about today is Pythagorean identities. What I'd like you to do is draw this circle and make these triangles. Right now, what we're going to do is we are going to focus on the first quadrant. If you guys would, right here, put this is your x value, this is your y value. So what I want you to do right here, this length you can clearly see is a 3. And this length right here in that triangle is a 4. So what I'd like you to do, all right, to help us focus in on just this triangle where I'm right here, what I'd like you to do is I'd like you to make another little triangle right here. Oh, not like that. Let's try here. Just to the side. I'm just going to go like this. Right there. Good. That's close enough. Okay. So what I want you to do is I still want you to call this 4 units and call this 3 units. And I want you to focus at right here. This is theta. So if you would, draw this triangle. Right now, we're dealing with quadrant number 1. All right? So if I said, what is the sine of theta, how would we find the sine of theta? Now, this is a 3, 4, 5 triangle. Does everybody understand that? You should know that the 3, 4, 5 right triangle. You probably have seen it before at some point, hopefully. If you're not sure how I got it, it's 3 squared plus 4 squared equals 5 squared. Okay, so that's how I got the 5, in case you're wondering. All right? What is the sine of theta? It's the opposite over the hypotenuse. What is the cosine of theta? It's the adjacent over the hypotenuse. And what's the tangent of theta? It's equal to the opposite over the adjacent. So if you would please just rewrite in case you need it for later. So SOHCAHTOA. So write SOHCAHTOA. Make sure you know that this is the opposite over the hypotenuse. This is the adjacent over the hypotenuse. And this is the opposite over the adjacent. Just remember when we're doing this, you always draw the arrow going across. That labels this the opposite side. Here's your hypotenuse, and this is your adjacent side. So these are all the Pythagorean identities dealing with quadrant 1 for a 4 and a 3. But what I want you to understand, even though we have the same right triangle in quadrant 4, they're not going to be the exact same, because now we have, these are all x values that are positive, but here we have an x value that's positive, but a y value that is negative. Okay, so in your circle right here, make sure you put that's going to be a 5, this is going to be a 5, this is going to be a 5, this is going to be a 5. But when you're trying to figure out, we're not going to do all these. We're just going to do, I think we'll do quadrant 3, and then we'll do some examples in the Khan Academy. Here, I want you to put -4 because it's going over -4. Here it's a +3, but down here it's a -3. Just like here is also a -3. So where you are in the circle is very important, like which quadrant you are in. So right now we're going to look at quadrant number 3. So I'm going to make the triangle look like the triangle from quadrant 3. So right here I'm doing a new triangle. There's our triangle from quadrant 3. So if you would, we're going to put -4 here. We're going to put -3 here. This is a 5. That length is just 5 units. So don't worry about these. This is your R value. This is your radius of the circle, okay? Now, in the Pythagorean identity, you guys know a squared plus b squared equals c squared. But what I'd like you guys to do is underneath a squared plus b squared equals c squared, please write this. Your x value squared plus your y value squared will always equal your radius squared. So I want you to see the connection between these two concepts. So right now, please put this in your journal. So now that you have this written down, here's what I want you guys to do. Check this out. You guys remember SOHCAHTOA, but we're going to change things up a bit. Ready? I want you guys to write the sine of theta. the cosine of theta, and the tangent of theta. We are going to do things not in terms of the opposite and the adjacent and the hypotenuse. We're going to do everything in terms of x, y, and r. Your sine of theta will always be the y value over the r value. The cosine of theta will always be the x value over the r value. And the tangent of theta will always be the y value over the x value. So these are going to be your new super duper shortcuts to help you when you're dealing with these Pythagorean identities, okay? Sine is y over r, cosine is x over r, and tangent is y over x. Just remember, from yesterday or the previous day, remember how we found our x and our y coordinates? What was the x value always? It was the cosine of theta, and the y value was always the sine of theta. So that kind of makes sense if you see how this connects to these rules right here. Okay? So right now, let's take a look at this. In quadrant number 3, all right? In quadrant number 3, what's our x value in quadrant 3? Our x value is -4. And what is our y value? It's -3. And what's the r value? 5, right? So check this out. If I said, what's the sine of theta in quadrant number 3, what would you guys say? It's the y over the r. So what are we going to say? -3 over 5. Boom, you're done. What's the cosine of theta? The cosine of theta is always what? X over r. What's the x value? Boom, -4 over 5. If I said, hey, what's the tangent? What's the tangent of theta? Boom. We got what? Negative what? -3 over -4. But what happens to those? They cancel out and become what? +3/4. So this is where you got to be careful. Check this out. We said we were in what? Quadrant 3. What did we get as the tangent? 3 over 4, correct? Now look what we got as the tangent over here. Can you guys see the tangent is the same in quadrant 1 and quadrant 3? So guess what the tangent will also be the same as in quadrant 2 and quadrant 4. So tangents will be equal in 1 and 3 and also in 2 and 4. Sines will be equal in quadrants 1 and 2, and cosines will be equal in 2 and 3 because they'll still have the same x value, okay? So I want you guys, you know what, we'll just write that down real quick. Ready? The tangents will be equal to each other in what quadrant? Quadrants 1 and quadrant 3. The sines will be equal in quadrants 1 and 2. And the cosine of your theta, I'm going to put the tangent of theta, the sine of theta, and the cosine of theta will be equal in quadrants, let's see here, 1 and 4 and 2 and 3. Oh, I also got to say 3 and 4. I'm going to put and. The sine will be 3 and 4 will match. And cosines will match in 1 and 4, and they will also match in 2 and 3. So you got to know which quadrant you're going to be in. So sines are going to match in quadrants 1 and 2, and also they'll match in 3 and 4 because they'll have the same y value. Cosines will be 2 and 3, and also 1 and 4. And then the tangent will be equal 1 and 3, and it'll also be equal in 2 and 4. So here we go. And 2 and 4. So what we're going to do now, all right, what we're going to do now is we're going to go to the Khan Academy. We're going to take a look at one problem, and I want you guys to do this problem with me, if you would, please, okay? So right now, let's take a look at it. All I want you guys to do is simply write 3 things down, okay? Write down we're in quadrant number 3. Write down this is the sine, and we're trying to find the value of cosine. So I want you guys, we're starting in quadrant 3, okay? We have the sine, and we're looking for the value of cosine. So please write those down. All right, let's take a look at this right now. Just remember, the sine of theta, everybody, the sine of theta is always the y value over the x value. So what I'd like you to do, when you guys are starting this problem, I want you guys to write down what is x equal to, what is y equal to, and what is r equal to. And I apologize, it's y over r. Why did I do that? I don't know. There we go. Sine is always y over the r value. So what is what's the r value? Our r value is 2, and our y value is negative radical 3. So right here, put r is 2, y is negative radical 3, and we are going to find our x value, okay? So all I want you to do right now is put the sine of theta is y over r. That they've given us this. They've told us we're in quadrant number 3. In quadrant 3, your x's are negative and your y's are negative in quadrant 3. So that's going to be very, very important. So let's go over to the blackboard and we'll solve this out. Ready? The new formula, x squared plus y squared equals r squared. What will x squared always equal? R squared minus y squared. Or you could say x equals the square root of whatever r squared minus y squared is. Here we go. What is the radius squared? What would you guys say? The radius squared is 4, right? If I plug this in, if I say what is negative radical 3 squared, what's going to pop out? Just a 3. So if I square my y value, I just get minus a 3. Well, what is 4 minus 3? It's just 1. So our x value is 1. But we got to be careful, because our x value is 1, but this is where we got to be careful, everybody. Technically, where are we at? We're in quadrant number 3, which has to have a what? Negative x value. So I'm going to say my x value is at a negative 1. So what is the cosine? Is x over r, right? So what am I going to put? Negative 1 over 2. Whew, this is where you got to be very, very, very careful. The quadrant determines whether the x value is going to be what? Positive or negative. So I'm going to type in negative 1 over 2. There we go. Remember, it says express your answer exactly. All right, let's do one more here, okay? This is going to go a lot faster now. So in your journal, all I want you to do right now is to write this down. You are in quadrant 4. Okay, we're in quadrant 4. We have the cosine, and now we're trying to find the value of sine. So here we go. Write this one down, and this one down. I'm going to pause while my students do. All right, so listen up. What we're going to do right now is I want you to write the cosine of theta equals the x value over your r value. So right now, put x equals, y equals, r equals. And we're going to say it's what? 9 over 19. So what's our r value? 19. What's our x value? 9. What are we looking for? We're looking for our y value, okay? So right over here, if we know x squared plus y squared equals r squared, our y squared will always be r squared minus x squared. Here's a quick little formula. If you want to use it, you can. It's always the square root of r squared minus x squared. So I need your help here. 19 squared, I believe, is 361, minus 9 squared, which is 81. If we take these away, all right, if we do 361 minus 81, what'd you guys get? 280. Now, guys, we're going to learn how to simplify this radical. We're going to be looking for two numbers that multiply together that equal 280. So I know that 40 times 7, like 4 times 7 is 28, so 40 times 7 is 280. Now from here, what two numbers multiply together to equal a 40? I'm going to go with a 4 and a 10. This is going to break down to a 2 and a 2. This guy breaks down to a 2 and a 5, but there's only square roots look for groups of 2, so it looks like I can only pull a 2 out. So a 2 comes out. I got 2 times 5, which is 10. So I got basically, looks like I'm still stuck with a what? 70 on the inside. So here's what I want you guys to write. I want you guys to write 2 radical 70 for the y. 2 radical 70, but this is where we have to be careful. Our y value in the fourth quadrant, guys. What's going to happen in the fourth quadrant? Our x value is positive, but what happens to our y value? It's negative, so I got to make my y value negative. Holy cow. What is the sine of theta? What is my y value? Negative 2 radical 70 over 19. That's what I'm going to type in. That's called the what? Exact answer. All right, so I'm going to pause. I'm going to get my calculator just to make sure I didn't screw up. Just making sure we had 19 squared minus 9 squared, which was 280. And what did I say our radical was? 2 radical 70, which should be the same as the square root of 280. So see how these match? So this is the simplified version of that. So now I feel a lot better. Right here, I'm going to say my sine is negative 2 radical 70 all over the radius, which is 19. That's our exact answer. Holy cow. That's all you guys got to do. Like, what? So I'm going to do one more. If you guys got this, you can go ahead. If you don't, if you want me to do one more, you can follow along. I'm going to do one more just for you guys. This one's going to be easy. This is in quadrant 1. Just remember, quadrant 1 is where I like to live. Everything's positive. All right. The sine is always equal to the y value over the r value. I'm looking for cosine. Just remember, the cosine of theta is always equal to the x value over the r value. So right now, we know the y value. It's what? 11. We know the r value. It's what? 61. So all we need is the what? X value. So here we go. We're going to do 61 squared minus 11 squared. Take the square root of that, and that'll give us our x. So I'm going to do that in the calculator right now. 61 squared minus 11 squared. Voila, what do I get? 3,600. So we take the square root of that guy right there, which we know is going to be, oh, it's going to be 60. But I'm just going to do it anyways. Here we go. Boom. So right now, I know my x value will equal a 60 because this was the square root of 3,600. So now I'm going to put 60 right there. This is, by the way, these right here, guys, these are called a Pythagorean triple. A Pythagorean triple is when you have three numbers, like the most common one is the 3 squared plus 4 squared equals 5 squared. But this is another Pythagorean triple, that 11 squared plus 60 squared equals 61 squared. That's another Pythagorean triple. So here we go. We got our x value. So what's our final answer going to be for this guy? The cosine of theta is going to be our x value, which is 60, over our r value, which is 61. We just type it in exactly like that because we're in quadrant number 1. If we were in a different quadrant, then I got to make the determination whether the x value would be negative or positive in that quadrant. But I'm just going to type in 60 over 61. And there we go. All right. So in review, let's go real quick. In review, what did we change? We went from SOHCAHTOA that you guys were used to doing, and now we're dealing with what? These right here. And just remember, when you guys are doing it, it depends where you are. Just remember, your x's are all positive in 1 and 4. Your y's are all positives in 1 and 2. And your x's are always going to be negative in 2 and 3, and your y's are negative in 3 and 4. So make sure you guys have these in your journals. Not journals, but just journal. And make sure you guys get this done. Good luck.